Hi, thanks for the introduction. My name is Mete Atamel. I am a developer advocate at Google. And today I want to talk to you about choreography versus orchestration in serverless microservices. Before I start my talk, I realized the platform for this conference is really good. I haven't used it before, Rocket, I guess. And I will be looking for questions in there. So if you have any questions that come up during the talk, just ask in the chat and I will try to stop and answer them as we go along. And the only thing I'm asking from you is please send me feedback at the end of this talk. So when I finish the talk, please, if you can give the stars and also some feedback if you have on what you like about the talk, what you don't like about the talk, and if there's any other topics that you like to see, that would be very valuable for me. So please do that if you can. All right. The way this talk is going to go is that first I want to explain to you what I mean by choreography and orchestration, and in what situations choreography is better, in what situations orchestration is better. Then I want to look at this landscape of orchestration and choreography and look at some of the services and tools that exist in this area. We won't get into them too much, but I just want you to understand like some of the main tools in that area. Then we'll zoom into orchestration a little bit more, and we're going to look at Google's Workflows, which is an orchestration service. And my point there is to show you what kind of things you can expect from an orchestration service. Okay? And then finally, in the last part of the talk, we're going to look at a case study where we built an application using choreography initially, and then the problems that we had, and how we changed it to use orchestration, and the things that we learned. So for me, the last part, the case study, is the most valuable part of the talk because it's going to talk about a real case study, and there's also learnings there. So stick around. But before we get there, I just want to set the stage a little bit with some terminology and some of the landscape. Okay. And the presentation, it's already on Speaker Deck, so feel free to grab it there. And the application that I'm going to show, it's already on GitHub as open source. And I'm going to share the link at the end of the presentation. All right. So what do we mean by choreography versus orchestration? And let's answer this question with a simplified e-commerce transaction. Let's say you're building an e-commerce transaction, okay? And in an e-commerce transaction, typically in a simplified e-commerce transaction, what you have is that you need to receive orders, then you need to authorize and charge credit card, then you need to prepare, ship the item, and then you need to notify the user. This is what happens, at a very simplified level. Now, if you want to design a system to handle this, of course, one easy way of doing this is that put all of these functionalities in a single app and deploy that app as a single monolith, and hope that it works, right? So that's what we used to do, and as most of you probably know, monolithic applications, they have lots of issues, and since then, now we went through phases, and now the phase that we have is this microservices phase, where instead of having a single monolithic application, you have small services that do one thing at a time, and then they just call each other. So in this model, for example, if you are running on Google Cloud, you might have a front end for receiving the request running on App Engine. Then you might have a payment processor for dealing with authorization of the credit card. And maybe this is running on Cloud Run, which is a container service on Google Cloud, so it runs containers. Then maybe you pass it to a function on Cloud Function that deals with shipping the item. And finally, maybe you call a notifier to notify the user using email or something like that. So in this simple model, you have each service doing one thing at a time, and each service just calls the next service in the chain, right? Now, in this simple REST-based approach, the pros is that it's better than a single monolithic application. You have single microservices that do one thing at a time, and it's easy to reason about them. And you can deploy them independently, and all those good things about microservices. And this is very easy to implement, right? So you deploy a service, and all it needs to do is it needs to know what service to call next. So it's easy to reason about. On the other hand, you already have too much coupling between services. Each service has to know what the next service in the chain, and that's creating this coupling that you don't really need, and that causes problems later when you need to update a service. Then you need to think about the next service in the chain, and so on and so forth. Each service can be a single point of failure because, let's say, the notification service or the payment service fails. Then what happens? The whole chain kind of breaks. Of course, when things fail, you want to apply some kind of error policy or retry policy. And these kind of policies you need to implement in each service. So it takes time to do it in each service. And for me, the most important problem is that this whole transaction, right? Like, each service could make sure that it does its work, but there's nothing watching that the whole transaction is actually successful. And that's a problem in an e-commerce kind of application. Now, to deal with this problem, you can take what's called a choreography approach, also known as event-driven. And in event-driven architecture, instead of each service calling each other, you can have a message broker, an eventing backbone, and you can have each service receiving messages that it's interested in, and then emitting messages that it wants to notify other services about. So in this case, the front end will receive the request, and it will say, okay, I received the request message. Then the payment processor will pick that message, and it will say, okay, I received the request, I did the payment, so the payment is processed, so on and so forth. Now, in this model, it works, and it allows you to kind of build these loosely coupled kind of services. But imagine a real e-commerce transaction. Something like this is probably more closer to real world, where you have to read a database, you have to check whether something is in stock or out of stock. Then depending on that check, you want to do certain different branches. And then maybe down the line, you want to make a call to third-party APIs like the supplier's API or the SendGrid and things like that. So imagine this kind of like flowchart. This is more complex, but it's not complicated in the sense that you can tell exactly how things should work. But imagine doing this in an event-driven kind of way. That's a little bit difficult, like taking this flowchart and making it an event-driven services in architecture. It's not that straightforward, and you kind of lose this flowchart. So the pros and cons of event-driven architectures is that first, the services are loosely coupled, which is really good because you don't want services to depend on each other if they don't need to. Each service can be scaled and changed independently, again, without having to think about the next service in the chain. You don't have a single point of failure per se. So if a service fails, the rest of the services will still send messages and emit messages. The whole transaction might not work, but at least part of the transaction kind of works. And eventing in general, it's very useful if you want to extend your system. So if you want to add a new system, a new service to your architecture, it's basically just deploy the service and configure the message broker to let that service know, to route the messages that service cares about, right? And then the service also needs to decide whether it wants to emit messages or not. But it's very easy. You don't have to worry about too many things to extend the system. Now, the cons of this approach is that now it will be difficult to monitor your architecture because your services will receive and emit messages, but if something fails, you won't immediately see where it failed. You have to kind of guess where things failed, and you have to look at the logs of each service to figure out what happened. The errors and retries and timeouts are still hard. Like you still need to implement those. So if something goes wrong, you still need to retry things, and this needs to be implemented in each service. And this business flow that I showed you with the flow chart, you kind of lose that. Like you take that and kind of break that down into services that emit messages, but you can't point to a place where this flowchart is captured in your architecture anymore. And that's a shame because that business flow is really important to understand the system. And this problem of who ensures that the whole transaction is successful is still a problem. You still need to kind of find a way to make sure that your transaction, the whole transaction, is actually successful. Now, another approach you can take is called orchestration. And in this approach, you kind of have an external service called Orchestrator that manages the flow of how things should work. So in our example from before, you might still receive the orders in a front end, but the front end will kickstart an orchestration, and then this orchestration will go to the orchestrator, and the orchestrator will say, okay, now I need to call the payment processor, I need to call the shipper, I need to call the notifier. So it will do that in that order. And this orchestrator will capture the business flow, how it's supposed to be, and we'll talk more about this later. and it will call the services in the order that it's supposed to happen, and it will also be able to get results from a service and pass it to the next service, right? So it will kind of orchestrate these calls and pass in inputs and outputs and all that kind of stuff. Now, in this model, the pros is that now you have a central place where you can capture the business flow in the orchestrator, and this business flow can be, written in this workflow definition that we'll talk about, and it can be source controlled, it can be versioned. So there's a lot of things that come out of this that's really good for your architecture. In orchestration, you have this notion of steps and what happens in each step. So when something fails, it's very easy to see which step failed. So each step can be monitored, and then you don't have this, it's like there's no ambiguity based on what failed. You'll see it very clearly which step failed. Now, these errors, retries, and timeouts, you still need to worry about them, but at least they can be centralized in the orchestrator. The orchestrator can do these retries and timeout logic instead of each service having to do it. In orchestration, you usually depend on simple REST calls, so you don't have to deal with the events and the complexity of multiple event types. And the nice thing is that the services are still independent, right? So you still have these independently deployed services, but they are kind of brought together into what I call a temporary monolith, basically, right? So you kind of bring them together temporarily into this orchestration. So you kind of have the benefits of both independent microservices, but also the kind of the benefits of having things bundled together in a temporary way. On the other hand, an orchestration service, it's a new service that you need to learn and maintain. And orchestration can be a single point of failure. So if you choose an orchestrator that's not reliable or resilient or scalable, things can go wrong. You lose a little bit of flexibility because instead of having eventing, you have orchestrators. So when you deploy a new service, for example, you need to worry about deploying the service, also changing the orchestration. So it's a little bit more involved. And you also still need to think about your transaction in terms of failed steps. So if a step fails, orchestrator is not going to recover from that automatically, right? So the transaction will still fail. But what orchestrator can do is that it can apply a compensation step. For example, if the payment step failed, the orchestrator maybe can do a chargeback and give the money back to the user or something like that, right? So you have to think about these compensation steps. Orchestration can help for that, but it's still something that you need to think about. So the question is, okay, which one should I use? Like choreography, orchestration, which one is better or worse? And then, as in every software engineering problem, it really depends on what you're trying to do and how much flexibility you want and how much structure you want in your architecture. But there are certain things that I look for in my problem and in my architecture that kind of guides me whether an event-driven system is better or whether an orchestrated system is better. So if, for example, my services are not really closely related, for example, the payment processor doesn't really need to know about notification service, really. So in those situations, maybe choreography is better because they can just send events to each other and they don't need to know about each other. Or, for example, if the notification service can live in some other kind of transaction, then it's usually better to use event-driven systems because you can easily plug that service in different kind of contexts, right? So if you have that kind of services and contexts, then usually choreography is the way to go. But on the other hand, if you have a business logic, if you have a flow in your system that you can define in a chart, then maybe orchestration is better in that case, because that chart has lots of value, and maybe you want to maintain that value of that flow chart in an orchestration. And also, if you have services that are always deployed together in a certain order, then maybe orchestration is better, because why have this like flexible eventing if your services are always like deployed the same way in the same order? And also, in orchestration, you're staying in REST calls, so it's not eventing. It's not a reason to choose orchestration, but it's kind of like a side effect. But it's a really nice side effect, right? Because staying in rest kind of simplifies your architecture. So maybe if you want to stay in the rest world, orchestration is the way to go. Of course, you can also take a hybrid approach and orchestrate the things that you want in an orchestration, and then let them connect with other orchestrations using eventing, right? So in this model, you orchestrate things that make sense, but if they need to signal other orchestrations, you use eventing because they don't need to be bundled together, right? And this is a totally valid approach as well. And I see more of this hybrid approach in the real world than just orchestration or just event-driven. All right. So that was a really quick summary of what is choreography, what is orchestration, what makes sense, and in what situations. Let me just double check the chat. I'm checking the session chat. Let me switch to event chat. I don't know. Yeah, I don't see any questions right now, I think. But if there's any questions, please ask in the session chat, and I will try to answer as we go along. So now let's look at the landscape in this area. Now, in terms of choreography or event-driven landscape, we have, this event-driven architectures, they've been around for a while, and because of that, there's lots of tools and services in this area. So whether you're on AWS, Azure, Google Cloud, there's a number of products that you can use. So AWS has EventBridge, for example. Azure has EventGrid. Google Cloud has PubSub for low-level messaging, but EventArc for application-level integration. And there's open source projects like Kafka and RabbitMQ and things like that. So there's a lot of choice here. I'm sure you know some of these already. So I won't spend time explaining what they are. In terms of orchestration, orchestration is something more recent. And because of that, there's more limited support. So on AWS, there's step functions for mostly like orchestrating Lambda functions. Azure has logic apps, and Google Cloud has workflows and Cloud Composer. Workflows is for service orchestration, and Cloud Composer is for data orchestration. And there's open source projects like Apache Airflow, for example, that Cloud Composer is based on. That's also, it's an open source project that you can use as well if you like. Now, I also did a comparison of step functions to logic apps to workflows, just to see like what features each have and how they compare. And I won't go through this table in detail, but as you can see, the basic features are there for all three, with slight differences here and there. And my chart is probably, my table is probably out of date by now. So most of the stuff on workflows that's in preview, they're now available. If you look at more advanced features, then what I see is that logic apps, Azure logic apps have more advanced features. And then workflows is kind of catching up with features to logic apps. But step functions, they seem to be more geared towards AWS ecosystem and AWS Lambda. So they don't have most of these advanced features that I looked at. But no matter where you are, I think you have the base level orchestration from these services. Then there's also this serverless workflow from CNCF, which is an open source workflow definition. So it's a specification for defining workflows. But it's also beyond that, beyond just specification. It's also for developer SDKs. So running workflows in different programming languages, the runtimes for workflow, and also the tooling around workflows. So they're being worked on from what I see. So I haven't tried them in a real world kind of setting, but from what I see, the specification is out there, and there's these SDKs and tools that are being built. None of the cloud providers, they implement this serverless workflow yet, but it's something that to keep in mind, and maybe at some point in the future we can see some of the cloud providers implementing this. But it's good to see that there's an open source alternative that's coming up as well. All right, now that we know the landscape, now I want to look into Google Cloud Workflows, which is the orchestration service of Google Cloud, and just some of its main features and then we'll get into the case study and take a look at the case study. So what is Google Cloud Workflows? Workflows, it's a service from Google Cloud that allows you to orchestrate and integrate other services, okay? And it can integrate your code running on Google Cloud. So if you have code running on App Engine or Cloud Run or Cloud Functions, you can include those in your orchestration. It lets you orchestrate Google APIs as well. So any Google Cloud APIs or any Google APIs like Gmail or Hangout or something like that, you can include them in your orchestration. And it even allows you to include external APIs. So if you are calling an external service from Google Cloud, as long as that service is publicly available, you will be able to include it in your workflow definition. This is good because when you're building apps, usually it's not just your code or just code and Google Cloud APIs. It's kind of a combination of your code, APIs within the cloud, and APIs outside the cloud. And workflows allow you to kind of bring those all together into a single orchestration. Now, how do you define this orchestration? There is a workflow definition language. It's either YAML or JSON syntax. And here I'm showing a YAML example. So remember, in our previous simple example, we had the payment processor, shipper, and notifier. So if you want the orchestrator to make call in this order, what you can do is you can define steps, and these steps you can call them whatever you want. So here I'm calling it process payments, ship items, and notify user. Then in each step you define what happens. So here we are saying that, in process payment step we are making an HTTP post to this URL, which is a Cloud Run URL, and we are passing in these payment details that we received from the previous steps. Now, once workflows makes this call, it will receive a result, and we can capture that result in process result. And then we make another call in the next step to ship the item, and we pass in the result from the previous step. So you can see how the calls are being made, and you can see how the body is being, the input is being provided, and how you can capture the result and pass it to the next step. So this is step sequencing that I just show you. You can do things like serverless pause. So if a shipper, for example, let's say after shipping, you want to wait certain time before notifying the user, you can add a pause in your step, and workflows will wait for that. And then you can pass in data between steps. And there's a very simple JSON parsing syntax as well. So when you pass in the data, then when you get the result back, you can parse that result and get the part of the JSON that you care about. But it's kind of limited JSON parsing. And then you can do things like errors and retries. So for example, if the payment processor is failed, maybe you want to try 5 times before giving up. And maybe you want to try with exponential backoff kind of way. So you can define this 5 times an exponential backoff policy within your step or globally if you like. So this is very useful for global error handling. And then depending on the result of a step, let's say the shipper function returns a success HTTP code. If that happens, you can branch to notifier and let the user know. Or if there's an error, you can branch to another Cloud Run service pager and escalate to support or something like that, right? So this branching can happen within your orchestration without you having to write the code. And you can do conditionals. So let's say you are reading a database and check a value and determine whether something is in stock or out of stock. So this check usually happens within the code, but you don't have to. You can do this conditional checks within orchestration. So that allows you to kind of do this simple conditionals within orchestration rather than deploying a service and checking in the service. And if you need to do third-party APIs, that's totally supported and makes your orchestration more useful because you can call third-party APIs. And finally, you can define sub-workflows. So these are workflows that can be called from different workflows, kind of like methods in code, but for workflows. You can connect to Google Cloud services using connectors. So these connectors make it really easy to call other Google Cloud services and also have the logic to retry if something fails or wait for long-running operations. And if you want to make a call to a service, get a bunch of results, and do an iteration on those results. You can do that, or if you want to have a human in the loop kind of orchestration, where someone gets a call back. Like let's say you make a call and then the user has to approve or deny that call. Then you can use callbacks for that. So that allows you to write orchestration that involves a person in the loop, basically. So to deploy a workflow, you define your workflow in a YAML and deploy. And then once it's deployed, you can execute it. This deploy doesn't execute. It just deploys it, and then you execute it. And then you can see the execution like this. Of course, all of this is in the UI as well. So you can define your workflow in Google Cloud Console. You can see a visualization of your workflow, which is very useful to see what's happening visually. And you can execute and run it here as well. Okay, so that was, again, a very quick overview of Google Cloud Workflows. Now, let's talk about, for me, the most useful part of the talk, the case study that we have. So we have this application called Picadaily. It's a picture sharing application that me and my coworker initially wrote last year in an event-driven kind of way. But let me talk about the application first. So this application, it has this front end. And in this front end, you can upload a picture. And once the picture is uploaded, we use machine learning to determine the labels of this picture. So you can see that this picture is, the labels it has is like dish, food, cuisine. This picture is like landmark, tower. So these labels, they come from Vision API. We also detect the dominant color in the picture. So you see that around the picture, there's a border, and this border comes from the dominant color of the picture. And we do that as well, again, with Vision API. So the user uploads a picture, and with that, we extract the labels, extract the color, and display them this way. We also have a collage area where we combine the 4 most recent pictures that the user uploaded, right? So it's a very simple app, and actually there's a workshop around this. If you want to build this app yourself, there's a workshop that you can go and do it yourself if you like. And the way we built this initially was something like this. Even though it's a simple app, it has many services. And then the way this was built initially was that the user would upload a picture to an App Engine front end, and this picture will go to a cloud storage bucket, which is a place to save files in Google Cloud. And once the picture is saved here, this will trigger a number of events. The first event will go to a cloud function called image analysis that will analyze the picture and save the results to Google Cloud Firestore, which is a NoSQL database. So we will get the labels of the picture, the color of the picture, and save it to Firestore. The second event will go to a Cloud Run service, which runs a container. It's called Thumbnail service. And this will take the picture in bigger size and make it a smaller version of it. But this goes through PubSub because Cloud Run at the time didn't support direct events, so it had to go through PubSub. Then the third service is called Collage service that runs on a schedule from Cloud Scheduler, and it will go and figure out 4 most recent pictures from Firestore metadata, and it will get those thumbnails of those pictures, and it will save them into a collage. And finally, the last service was a garbage collection service. If the user deletes a picture, then we delete the thumbnail and we delete the metadata of the picture. And this happens through Event Arc, which is a new service for getting events to Cloud Run. So you can see that even though it's a simple app, there's already a few services involved, and we have different event types going to Cloud Functions, to Cloud Run service, and the image garbage collection service, and also an event coming from Cloud Scheduler. And because we had different event formats, we had to handle them differently. For example, the Cloud Function would get the file creation event directly. So the event would be received directly, so we can get the name and the bucket directly. Whereas the Cloud Run service, the thumbnail service, will receive a PubSub message. So we are receiving a PubSub message. And then from the body of the PubSub message, we look at the data field. And from there, it's base 64 encoded, so we have to decode it. and then we'll get the file event. So it's kind of wrapped into a PubSub message. And then in garbage collection service, we are receiving events through event arc, which is a cloud event, and it goes through audit logs. So you can see that we are receiving the cloud event. Then we look at the audit log from the cloud event, and then we get to the actual file event. So you can see that it's already kind of complicated, right, with these eventing formats. Now, when workflows came along, became GA at the beginning of this year, we said, okay, why don't we take this app and make it an orchestrated app using workflows? And this is the architecture that we came up with. And at the first look, this might look more complicated because there's more things in the architecture. But actually, everything in the red boxes, they're in workflow. So it's basically a single service. It's the workflow service, right? So if you think that way, then it's not actually that complicated. It's actually simpler than previous service. And the way this works is that the user still uploads the picture. It still goes to the cloud storage bucket. So there's nothing different there. And then there's still an event that goes from the cloud storage to a cloud function. But then the cloud function starts an orchestration. And this goes to workflows. Now, workflows looks at the event type, figures out if it's object creation, object deletion. Then if it's object deletion, it will delete the picture from thumbnails, and it will delete from Firestore. So this happens within workflow, not going to an external service. If it's a new object, then it makes a call to Vision API, again from workflow. Then get the data, transform the data, check if the image is safe. If it's safe, then save it to Firestore, and then create the thumbnail and create the collage by calling to Cloud Run services. Now you can see that in this model, some of the work is happening within workflow, and some of the work is happening by delegating to other services when it makes sense. And the reason for this is that if something is easy to do, like deleting a file or deleting an entry to the database, we do it in workflow because it's simple. But if it's like creating a thumbnail or creating a collage where there's a lot of steps involved, we rather do that in code. So we deploy services to do that, but then we kind of delegate from workflow by calling those services. Okay, and actually, let me show you the app quickly. Maybe we'll have time to show you. So the app here on Google Cloud Console, and here I have the app. If I upload a picture, let's just upload a quick picture and see what happens. I upload a picture of mine. And then this is now going to Google Cloud. But now if you go to workflows, we can take a look at this. Picadilly workflows, you can see that there's an execution that's happening right now. And if I click on the execution, I can see that the input that's being provided, the output is what I get from my execution. It's already finished, actually succeeded. But it's very nice to see this. And if I actually go to the source, I can see my my workflow in this nice way. So it's very easy to visualize what's supposed to happen. And if we go back here, and if I do a refresh, if I do a refresh here, I see a picture of me. And if we look at collage, like now I see a collage as well. So you see that things are working as they're expected to work. All right. So what we learned here is that when we made this transformation from choreography to orchestration, first thing was that we went from eventing to simple HTTP calls. And this was really refreshing because instead of dealing with 3 eventing formats, now we are dealing with simple HTTP calls. And this simplified our code and also our thinking in a big way. Secondly, yeah, as I said, we had less code, no reason to parse events, no service to do image analysis because we can do that from workflow, and then no reason for a garbage collector service because we can clean the image from workflow. So all of this resulted in less code. We also had less setup, so we don't have to set up PubSub, we don't have to set up scheduler, we don't have to set up event arc, all these 3 different systems. Instead, we had to set up workflow and create a YAML, but that was it really. So instead of 3 different services, we have one service that handles everything for us. And the error handling became really easy. So if something failed, if a service fails, we saw that immediately in workflow. In workflow will tell us the workflow, like the orchestration failed, and we can go to the step that it failed and immediately see which service failed and why. Now, so these were the positives. On the other hand, workflows is a new service to learn, and you are writing YAML instead of code. So it's something to learn and get used to. We constantly had this code versus YAML in our thinking. So should we do this in workflows or should we do this in an external service? And here, our guide is basically, if it's simple enough, do it in YAML. But if it's involved, if it gets too much, then break it into code and then deploy as a service and just call it from workflow. And also in workflows, you only have a single YAML file, so it gets out of hand pretty quickly. But you can use Terraform, for example, to break it down into multiple files and then combine them together before you deploy. Debugging, testing, logging, and ID supporting workflows is not mature yet. So it's not like code where you can just debug and see like locally. So you have to deploy and see how it works. So that's kind of limiting, but at the same time, it's fast enough that it didn't bother us too much. You kind of lose a little bit of parallelism with workflows, because instead of things happening in parallel, you have these steps happening in sequence. And you also lose a little bit of flexibility with eventing, right? Again, you need to change something. You need to change not just the service, but you need to also change the orchestration that calls that service. So these are the things that you should keep in mind as you're building your orchestration. And yeah, so that's it. That's all I want to tell you about choreography versus orchestration. So if you want to learn more about orchestration and workflows in particular, here's the link. Our workshop, it's something that you can build yourself. So this is the link for that. And we show you how to do it the event-driven way. And we also show you how to do it in a workflows kind of way. And if you want to check out the code, it's on GitHub. It's open source already. So please check it out. And if you have any feedback, please, at the end of this talk, please send me feedback about what you like about the talk and what you don't like. And if there's any other topics you like to see, that would be useful to know as well. So I'll just pause here. And I think we are almost out of time, but I want to just quickly check the chat to see if there's any question.
It was a question during your talk. Somebody asked you if the orchestration, it's a big monolithic app, but I think you explained it afterwards.
Yeah, I mean, the way I see orchestration is that it's a temporary monolith that you create, but without the drawbacks of monolith, right? Because the drawback of the monolith is that you bundle everything together and you deploy as a single unit. And if you need to change something, then you need to change and deploy the whole thing again, right? That's kind of one of the biggest drawbacks of monolith. Whereas in this case, yes, you're creating a monolith in the sense that you're putting services together, but services are still deployed independently. You need to if you need to change something, you can change a single service and just deploy that service. Of course, you need to change the orchestration YAML as well. So it's not as simple as just changing the service, but it's a trade-off that you have to pay, right? So yeah, it's kind of like a temporary monolith without most of the drawbacks of the monolith, I would say.
We have another question, but it's in the general feed. So if you can switch it, it's Emmanuel, the last comment.
Okay, so yes, the reason why choreography gained traction over orchestration was scalability, I think, because orchestrators were the bottlenecks probably. Question, do you think now it's desirable to use orchestration solutions like Google Workflow because it's easier to track the process and changes? Yeah, I mean, I agree. Like the event-driven systems, they were more scalable, but my experience with Google Cloud Workflows is that it's also really scalable. Like I never have to worry about whether workflow will handle the scale that I'm trying to do. So I think in that sense, like scalability is not an issue, especially when you're using a cloud-based orchestrator like workflows. So the question is, do you think now it's desirable to use orchestration solution like workflow because it's easier to track through process and changes? Yes, yeah, I mean, I saw this in our simple application. When we changed it from event-driven to orchestration, it was so easy to track what's happening. Like we could see like the orchestration, first of all, visually. And secondly, if something failed, immediately, like I go to workflows, here's the step, and I know exactly which service call failed, and I can see it in the logs of the workflow, and then I can look at the log of the service. So just that itself was worthwhile, I think. So yeah. And the second question is, do you know if it's more cost effective to use Orchestrator or Choreography from the point of view of the services that you need to use from the cloud provider? Well, I think that's a tough question to answer. So the services that you have, the actual services that do the work, they are the same, right? So you still need to deploy those services. But the way they communicate now changes. And now in our particular case, we switch from using 3 different services, PubSub, class scheduler, and event arc, and then we switch to using just one service, workflows. Now, which one is cheaper? Is it cheaper to use these 3 services, or is it cheaper to use just one service? Honestly, I didn't do the comparison. And I think, I don't know. I mean, my gut feeling is that they're probably comparable. I don't think one would be like, say, like 2 times or 3 times more expensive or cheaper than the other. So they're probably comparable. So I wouldn't worry so much about the cost of the communication between services, but rather focus on the cost of maintaining the architectures. So if you think that way, I think cost of maintaining an event-driven system is definitely higher, at least in our use case. Because in our use case, if we had to change something, like we had to deal with, okay, which messaging format is this or that format? Okay, now let's change it this way. And it's just like the complexity of the system was more. So you had to think more things when you're changing or adding something. Whereas in workflow, it's like, okay, here's the new service. Here's a step that needs to call it, and that's it. Like, that's all I had to worry about. So that makes it more easy to maintain, and I think the cost of maintaining your app will be much less. All right, I think someone mentioned maintainability cost. Exactly, Emmanuel. Yeah, that's exactly my point as well. Yes. All right, so I will pause here because I think we're out of time. So please send your feedback and enjoy the rest of the conference. Thanks for attending my talk. Thanks very much.